So here's another series that we're trying to see if it converges or not. Hopefully you're all okay with that. The 2 really has nothing to do with the 3n. At infinity is going to be much more powerful. So I could just think of this as 1 over the square root of 3n, as n equals 1 to infinity. But I'm just going to think of it as 1 over the square root of n. And I have a feeling that when I use this series with this one here with the limit comparison, I'm going to get a 1/3 or a square root of 3 or something along those lines. So this one here I know is P series. P is equal to 1/2, which is less than or equal to 1. So it's divergent. So that I know this guy's divergent, and if I can show the limit of this guy over this guy is equal to non-infinity or 0 or some finite number, I can show that this guy diverges as well. So the limit as n approaches infinity, I'm going to put the series that I know on top. It doesn't really matter. Oops, that's a typo. 1 over the square root of 3n minus 2. I flip and multiply. I get the limit of infinity. So this is 3n minus 2 over the square root of n. I'm going to multiply top and bottom by 1 over radical n. 1 over radical n. So these two cancel. And when I put this inside, I get 3 minus 2 over n, right? Because this radical just kind of slides inside there. Over, this is just the square root of 1. Well, this gives me radical 3. Oh, look at that. That's where that radical 3 came from. Okay, so is it wrong to use this series here and say it's a p-series divergent series? No, I just find this to be more attractive to work with. And since I got radical 3, I did not get 0 or infinity. I've done a good job, meaning I chose a series that I know diverges in this case. And you want to choose something that behaves very similar to this one here. So that means, so notice that I got radical 3. That means that these two behave similarly, right? So if this one diverges, so does this one as well, because I did not get 0 or infinity. So P series, P is equal to 1/2, which is less than or equal to 1, is divergent. And I use the limit comparison test. So, this is saying that this is a divergent P series. Limit comparison test, the conclusion is the same for this series as well. So I'm going to leave that as good enough. As long as I see those words, P series, P is equal to 1/2, less than or equal to 1, divergent, limit comparison, as long as I see those somewhere on your paper, and you show me the limit is equal to non-zero or infinity, you're good.